Hello, I'm Brooke Hollingshead. I am tonight presenting from class Math 510 Applied Linear Algebra, and we are going to do some work on solving systems of equations using matrices. So to start, we are going to first talk about coefficient matrix and the equation that we use to solve these, ax equals b, where A is our coefficient matrix, and I'm going to abbreviate for time. A is our coefficient matrix. So we take all of our coefficients, which are our constants that are attached to variables, and we put those all onto a matrix together. X represents all of our variables, and B are, if all of these were 0, so this is B right here. If all of these were 0, they'd be called homogeneous. But in our case right now, they are not 0. So for this case, we have n homogeneous terms. And what we're going to do is we're going to take these and put them together into an augmented coefficient matrix, where we put all of our coefficients and our inhomogeneous terms together in the same matrix, and then use what's called Gaussian elimination and row reduction methods to solve it. So I'm going to start by putting all of my coefficients. I don't have one for x1, so I'm going to put a 0 there, 2, 0 for x3, 1, 3, 1, 2, 1. And I have my vertical line to separate out my inhomogeneous terms from my coefficients. 0, -2, 1, 0. Okay. So this is what's called the augmented coefficient matrix. And it looks like this, because we took our coefficient matrix, all of our coefficients, and we put them with our inhomogeneous terms, and now we're going to solve them using Gaussian elimination row reduction. So 3 ways to do that. We can switch rows, we can multiply a row by a non-zero term, or we can add multiples of rows together also. So our goal with doing this is to get our leading term, so our top left term to start with, to be a 0, and everything under it to be, or to be a 1, and everything under it to be zeros. So I kind of think about this like reading. The top, we start at the top left of the page. We're going to work our way down and to the right. And I'm wanting my leading terms, meaning my first non-term, or my first non-zero terms, to be 1s eventually. And I want everything below them and above them to be 0s. So we're moving in that direction. So I'm going to start by doing some row swaps, and I'm going to switch out row 1 and row 3. And I'm going to kind of move quickly, because just for time, the essence of time here. So we have 1, 0, -2, 1, 0. I am a middle school teacher, so I'm used to doing things very slowly and explaining lots and lots. And as I have been practicing this and timing myself, I am taking way too long. So I'm going to try to explain a little less. All right, now I'm going to take row 2 and I'm going to subtract row 1. I have my leading term 0, that's or 1, that's what I want, but I need to get zeros underneath it. So I'm going to move that direction now. And these are currently what I'm doing are called forward paths. So as I'm starting to get these, so 1 minus 1, 2 minus 0, 1 minus -2, so plus, 3 minus 1, 8 minus 0. And this one's going to stay put. Okay, so now I have leading coefficient, or leading term. I need to clear out a 0 underneath that one. So I'm going to do now row 3 minus row 2. 1, 0. Still in my forward pass. I feel like forward pass is when we're kind of moving down and to the right on our matrix. And then once we're done doing that and we start moving back up and trying to clear out some zeros, that's when we're doing our backwards pass. 2 minus 2, 0 minus 3, 1 minus 2, 3 minus 8. Okay, so we are all set. We are in row echelon form. We're done with our forward passes. I have my leading coefficients being non-zero terms. Everything below them is non-zero. Now we're going to start moving back up, and my goal is twofold. I want these to become ones, and I want everything above them to become zeros. So we're going to start heading back up, and I'm going to take row 2, and I'm going to add it to, and add it to row 3. All right. 2 plus 0, 3 plus -3, 2 and -1, 8 and -5. This one stays put. And the last thing, well, not the last thing. The next thing I'm going to do is I'm going to want to change these leading terms to ones. So in order to do that, I'm going to do these both at the same time. And I'm going to take a half of row 2, and I'm going to take a -1/3 times row 3. And I can do them both at the same time because they're not going to affect each other when I swap them out like that. Okay, half, -1/3, -1/3, -1/3. Okay, last thing I need to do, now I'm at my last step, is I have my leading terms being 1, everything above and below is 0 except this guy, so I'm just going to fix that by adding row 1 to 2 row 3s. So 1, 0, now that's going to be 0. Okay, 1 plus 2/3, so 5/3, and 10/3, and everything else is good. 1/2, 3/2. And this is now what we call reduced row echelon form. And now that I have my leading terms being 1 and everything above and below them is 0, I have this in reduced row echelon form, and I can now have a new system of equations where this is my x1 term, and 5/3, the last one is going to be x4, and this is my x2 term. The first one is x1, and I don't have that. Half x4, and x3, and a third x4 equals 5/3. So basically we get our solution set from our new set of equations here, where if we solve them for each variable, so if we solve for x1, I get 10/3 minus 5/3 x4. I solve for x2, I have 3/2 minus 1/2 x4. Solve for x3, and x4 is pretty much whatever we want it to be as long as it's in the real numbers. And that would be your solution. Thank you.